Okay, so welcome to lesson 4B. We're going to turn to page 54, and when you turn there, we're going to be talking about how to write the equation of a quadratic function. So this whole section here is about writing the equation. What would the equation be? And if you look at number 1, it talks about George and Pat, and they wrote a quadratic equation with a vertex of 4, 8. You're supposed to look at the student's work and describe the similarities and the differences. So when we look at each one of their works here, look at George. Remember we have, what do we have? 2 vertex forms right here, and that the vertex was 4, 8. So if you recall, the vertex, we always use the letters H and K to represent the vertex. And I'm going to write down the vertex form. Oh, George has it right here already. So that A times x minus h squared plus k. Now, the tricky part is we don't really know what A is, and above in the directions it says just write a quadratic equation. It doesn't say which one, it just says just write one. So if you notice, they both wrote down the original equation here. That's awesome. They both wrote down the next step. That's awesome. And then what did we do here? Well, George just picked -1/2 for A, and Pat picked 1, which really means you don't have to write anything. So Pat picked a 1 right there. So what's similar and what's different? Well, they're all in the same form. They both use the vertex form, and they both substituted the vertex incorrectly for the x value and the y value, or h and k. So that's good to go. They're both correct on this. Let's actually write that down. While both George and Pat are correct, there's not enough information to create a unique equation, which means they're going to have different answers. That's all that means. So we're good to go there. But let's look at this worked example here. We're still on page 54. Here's how you actually find the equation of a quadratic function if you have 2 points. So here are the 2 points. We have point number 1 and we have point number 2. We have xy and xy. And the question is, write the quadratic function given the vertex. That's important because we know h and k. Let's write that down. So that'll be h and that will be k. And then they just give us a random point. This could be any point on the quadratic. So we have a vertex and we have a random point. So if you remember, the vertex is either the max or the min, depending on whether it's concave up or concave down. We don't know. They didn't tell us that. But we do know the point 4, 9. So that's going to be our x and our y. So here's how it goes. This is the worked example. I'm not going to work it out, but it's shown for you right here. We write the vertex form of a quadratic. So this was given earlier in the other lesson, right? We know this. And then we substitute in. We have the value of h. We have the value of k. That comes from the vertex. So that's 5 and 2. Remember, we're doing x minus 5. It's always opposite on the inside of the parentheses. And with this point here, we also know an x value. So we're going to sub that in right here. This will be x, and this will be y over here at the 9. And once you sub all the numbers in, the only variable that's missing is that a. It's the only thing. So it's just a regular equation right here. We can solve this. -2 minus 2. Square -1, and you just get 1. So it's 1a plus 2 is 9. Subtract 2, and then you divide. We can get the value of a. And then once we have a, look at all the stuff we have. We have the vertex form. We can plug in h. We can plug in k, and we can plug in a. You want to leave the x and the y, though. So here's the x, and remember y is f of x. And that is the equation of, this is the equation of the quadratic function that goes through the point 5, 2. It is a vertex. That's why we use vertex form. And the point 4, 9. Done. That is how they did it in their example. Now, suppose they don't give you the vertex. This is the next worked example. We can use a different strategy, but look, write the quadratic function given the roots -2, 0. I'm actually going to graph this, or I'm going to sketch it, not graph it. Sketch is like a quick graph. So -2 zeros about here, 4 zeros about here. This we'll call like root number 1, and we'll call this root number 2, because there's 2 different roots, right? And remember, the roots are the zeros. This is at -2, and this is at 4. Great. And the point 1, 6. So 1, 6 is like up here somewhere. So I am assuming, because it's the point 1, 6, that it goes through kind of like this. I don't know if that's the vertex. I kind of drew it that way. And here's the thing. It actually is the vertex. But it isn't going to be necessarily. It could be a point over here on the side or on this side, or maybe it's a point down there. So then how do we write the equation when we have 2 roots and then we have a point on the line? And it's very similar the way that we do it. But we're not going to use vertex form. That would be crazy, because they give us the roots. So we're going to use the factored form because that is what gives us the roots of an equation. Here's the factored form right here. We have a times x minus the first root, x minus the second root. Now, what can we plug in? Do we know any of these values? Well, how did their book do it? They called this one root number 1. Is that how I did it over here? I did. I used capitals, but same idea. So that's root number 1. This is root number 2. So they're going to plug that in here. That's root number 1. That's right here. And then root number 2 is right here. That's going to be a 4. And they're inside the parentheses, right? So that means that the signs will be opposite. So there's a minus in front here. But we just plug in a negative 2 and we plug in a positive 4. And then what else we got? Do we have an x and a y? That's this point right here is going to give us the x and the y. So maybe I should do that one in green. Kelly, do that one in green. So we got x and y. We'll plug that in right here. Here's the x, and this would be the y. So if you notice, we have substituted everything in. Oh, we have 2 x's. So x, root, y. The only thing left is a. So then again, 1 minus 4. That's going to be negative 3. And then 1 minus negative 2 is positive 3. So 3 times negative 3 is negative 9. And we have that a that's just kind of hanging out. The y value is 6. And you solve it and you get, ooh, look at that. That is ugly. But we get an a value that's negative 2/3. And look, that a value matches our picture. Because a has to be negative. It's concave down. That is the second worked example. So those are good examples to look at to help you figure out. When they say, hey, here's the following points that are on a quadratic. Like, what can we use? Which form would be best? So, what do you think? Let's check it out. If we have a minimum point, we're on page 55 now. Ooh, page 55. This is practice using each of the forms. So I'm going to write down the 3 forms. So here are the 3 forms that we know about general. And I wrote that down, factored and vertex. And again, we're on page 55. So what I'm going to do is I'm going to write down which of these equations should I be using if they give me this information. You know, which one should I use to try to figure out what is the equation if I want to derive the equation of the quadratic function. So let's look at the first one. They give us a minimum point, so I know that's a vertex, right? And then they give us the y-intercept. Well, the y-intercept is just an xy point. So because they give us a minimum point, which is a vertex, and the y-intercept, I would probably use the vertex form for that one. So we're going to write that down. Vertex, done, easy peasy. Part B here, they give us the points 2, 0, 8, 0, and 4, 6. These represent roots, the first 2, right? So if they're giving us 2 of the roots, then I can plug that into the factored form. That's probably what I would use for that one. C, we have 2 random points here. Now here's the best part. These are, we need to sketch this a little bit. Let me show you what I would do here. Can I show you what I would do here? Check this out. We have 175 and 450, 75. So where can I draw this? I'll draw this like right here. I want some room. So if I were to draw this, 100 is over here, 75 might be there, and then 450, 75. Okay, while these aren't roots, they're not roots, but they do represent a y value that's the same for both. And the thing that I know about parabolas is, it's probably like this, but it might be the other way. If I have a y value that's the same, the vertex will be exactly in the middle of that, right? The vertex will either be right there. If I have 2 matching y values, even if they're not roots, I can figure out in between them, exactly in between them, will be the vertex. So we'll have to do a little bit of work, but we can add these up. We get 550 and then divide by 2. What's that going to give us? 550 divided by 2 would be like 275, right? So that's where the vertex would be at 275, and then I'd have to find the y value. I don't have a y value to do that one. So we can't use the vertex form because I can't get that value of k. I can't get the y value for the vertex. Factored form, they're not roots, right? General form, what can I do with this? Well, there is a way to work it out with general form, but we're not going to go into that. I'm going to show you a little way here in a second using your calculator. Later. Oh, learn how to spell that, later. Calculator. We're going to learn how to use our calculator to come up with the equation as well. And honestly, you could probably use our calculator a lot on a lot of these. I'll show you how to do that. All right, last one. 3, 3, 4, 3, and 5, 3. How is that even possible? There is no way you can have 3 points like that, 3, 3, 4, 3, and 5, 3. That's not going to make a quadratic equation, but that doesn't work. So I'm going to write none for that one. That was ridiculous. All right, and then lastly we have intercepts. X-intercepts, those are roots, right? So they give us root 1, they give us root 2, and then they give us a point on it. That would be the factored form. So let's use the factored form on that one. That's what I would plug into there. Okay, we went through all the different forms and what we would use. Oh, and make sure that says factored because I pulled down vertex. Why'd I do that? Should be factored form on that last one. So now we have F and G. Why don't you pause the video and you try F and G, and we'll see how well you do on page 55 there. Pause the video and try F and G. Okay, so hopefully you figured out that F should be the factored form because they give us two roots here. And then G's a word problem here. We got to read it. It says he hits a baseball off a tee that is 3 feet high. So that means we're starting at the point, oh, that is ugly, 0, 3. That is ugly. 0, 3. All right, uglier. And then the ball reaches a maximum height. So maximum gives me a clue. This is a vertex, right, of 20 feet. That's the Y value when it is 15 feet from the tree. So we have X, Y. That is a max. It's a vertex, so I would use vertex form in that. Perfect. Now, let's look at a graph right here. We're going to look on page 56. We have quadratic functions that include given points. All right, so they want you to write the function. So we're going to do, maybe we'll do one or two of these here, and then I'll show you how to use your calculator. The first one here, it says the vertex is negative 3, 4, right? Okay, well, if the vertex is negative 3, 4, that is the high point or it's the low point. We're not sure which one it is until we look at the other point. So when we look at the other point, we know it's down here. Therefore, we know that this function goes down this way. And furthermore, because you went left 1, down 1, 2, 3, right? So you're left 1, down 3. This has to be symmetric. There's a line of symmetry here. So I know another point that exists would be right 1 and then down 3. There would be a point right here that matches up with the point given. So based on what they told us, I know there's another point. And that other point is negative 2, 1. So I should probably label that on the graph. We'll bring that over here. Negative 2, 1. That's that point right there. So now I have 3 points. Remember we talked about earlier in the lesson, as the last lesson, how many points do you need for a unique quadratic equation? The answer is 3. You need 3 points. Now, I'm going to do another one here. We have a vertex down here. They give us a root of 4, 0. Well, what can we do to figure out another root? It's the same idea. If the root is 1 unit to the right from the vertex, then another root would be 1 unit to the left. And that's based on the symmetry of the quadratic equation. So I know another point here, right, come on, right for me, would be 2, 0. So there's one side, the other side, oh, I was doing really well. Got it. Got him. The other point here would be 2, 0. So I'm just writing it over here, 2, 0. So now's the part where I show you how to use your calculator. You're going to love this, everybody. Pay attention. Now, we could work these out by hand, but we have the technology, right? Why wouldn't we use it? What I'm going to ask you to do, I'm going to ask you to clear the memory. I already got stuff in here. So I'm going to go second, hit the second button, and then memory, and then 712. That didn't work. Second, memory, 712. And that's going to clear the memory in our calculator. So right now I'm going to show you how to put these points in the calculator. So pay attention here. Go grab your calculator. Give us an ID, grab that calculator. You hit stat and then enter. And we're going to put the x values of the points. So we have negative 3. X value goes into the L1 here. And make sure, I just made a mistake. I used a minus because I used my keyboard. But make sure you use the negative. It's negative 3. And then the corresponding y value is an L2. I'm going to put a 4. And these do have to match up. Then I'll go back to L1. I'll put the negative 4, negative 4. And then its corresponding y value is 1. All right, so I'm looking at these points right here. I put in the vertex. I put in this point. And remember, I looked at the graph and I figured out the other point. The other point had to be negative 2, 1. So I'm going to throw that in as well. Negative 2, comma, 1. And let's put that in there. Now I'm going to show you a little trick. Ready? All of our points are in. I'm going to quit. And I'm at the home screen. Now pay attention here. Ready? We hit the stat button. Then we go to the right because we're going to calculate within our stats. We go down to choice 5, which is a quadratic regression. What a regression is it creates the equation from points that you give it. So we have L1 and L2. We're going to leave frequency list blank for right now. And then storing the equation. I hope you're paying attention. Pay attention to this. I want to store the equation that we come up with into the calculator. So I need to go find the variable y. I want to store this into y. So we hit the variable button, or vars. We go over to the y's, which is to the right. And then we hit enter because it's a function. And notice we have all of our y values, 1 through 9. I'm just going to hit enter again. And it says store the equation in y1. Easy peasy. Go down, hit calculate. Boom. It gives us the values of a, b, and c. And because I stored the value into y1, when I hit y equals, it's in there. Okay, now it does say negative 2.99999. You're just going to consider that negative 3. That's because of some calculator rounding error. All right, if I wanted to look at the graph of this, I could hit graph. And if you notice, I have that nice quadratic right there, which looks very similar to what I should have. If I want to turn on my stat plots, right, the plots, you go up here, you hit enter, you can hit turn it on, and then when I go back to my graph, I'll see those 3 points that I put in there as well. That was a lot of information. So now I'm going to try doing it with this one. I'm going to go a little bit faster because it's our second one. Here we go. So I hit stat and then enter. I'm going to put in the first point is 3 and then 2, right? So we have hit 3, we go down, we hit 2, we have 4, I go down, we get 0, and then the last point we figured out is down here, 2, 0. So 2, we go down, we go 0, and then we're done, so we quit. Second quit. And remember, where do we make the regression for this? It's under stat again. We go to the right, which is calculate. We go down to choice 5. Did you know you can just hit the 5 button? And we have to remember we have our x's in L1, our y's are in L2. I need to get the variable for the equation, so I'm going to hit, remember where that was? That was under vars for variables. We go to the right, we hit enter, and then we hit choice 1 for y1. Then we go down to calculate, and it tells us the equation again. Look at that. A is negative 2. So this equation, if I were to write it out, would be y equals negative 2x squared plus 12x minus 16. That's what's in y1. Some rounding error again. And then if I go to my graph, it kind of looks like that. And we're good to go. That is how you find the equation of a quadratic function if they give you 3 points. But you do need 3 points. Okay, so let's take everything we've learned so far, turn to page 60 here, and I'm going to look at how we can apply this. This is a word problem, and we're going to basically use our calculators to come up with equations. It says write the quadratic equation. By the way, you can do this by hand if you want to, by doing all the algebra, but I think the calculator just makes it real quick and easy, and we're less likely to make a mistake. Let's read this problem here. We have the amazing Larry. He's a human cannonball. He wants to reach a maximum height of 30 feet during his next launch. You know a human cannonball? Like shoot you out a cannon? His assistant, Dewan, estimates that this will occur when Larry is 40 feet from the canyon. So they have to give you information, and please be smart about it. They got to give you a route, or they got to give you a vertex, or some point where this could be simulated on a graph. And they basically are saying right here, he wants to reach a maximum height. So this is telling me this is probably the vertex, right? It's not probably. This is the vertex, a maximum height of 30 feet during his next launch. So when he estimates that it's 40 feet from the canyon, that's telling us we have 40 feet here. He should be up at 30. That's going to give us the point 40, 30, right? So that is the vertex. So the vertex is 40, 30. Let's write that down. Now, we need another point. They have to tell you it. When Amazing Larry is shot from the canyon, he is 10 feet above the ground. So let's assume that's at time 0, right? So this is the line x equals 0. He is already 10 feet above the ground, which means he's like this. Okay, so there's like some point, and then there's some other point over here, but he is going up, and he's going to come down. We need to find this other point. Let's change colors. We know this point right here is 0, 10, because he starts at 10 feet above the ground. So when time is 0, he is 10 feet above the ground. Then we have the vertex, which is 40, 30. Now, if we were to figure out, remember the vertex is right in the middle of this thing. How far is it from 0? How far is, what is this? Is it 40, 30? It is 40 units. What are we talking, feet? Yeah, it's 40 feet from 0. So where would The symmetric point, the point that lines up with this, how far over would that be? You can assume that would occur at 80, right? Because it's the same distance. There's symmetry through this line of symmetry right here. So this point at 0, 10 would end up at 80, 10. It maps there as well. Guess what we just did? We figured out one point that has to be on the equation. They gave us the vertex and they gave us the starting point of 0, 10. Now we can use our calculator. So I'm going to plug that all in my calculator. So notice how they are all in there. We have 0, 10. We have, ooh, I need to click on that. Let's go now, enter. There we go. 0, 10, 40, 30, right? Because when we're over 40, then it's up 30, and then 80, 10. And once I have all those numbers, guess what? We can go back. I'm just going to click enter again. Or you can go through all the processes. But the last thing I did was quadratic regression. So guess what? I hit enter, and these numbers are there all again. I can go to y equals, there's my equation. We're done. That's how we can come up with the equation. If I want to graph it, you can go to the graph. But look, our graph only goes to 10 and 10. So I need to fix my window a little bit to see it. I probably want to go over to at least 80, maybe, well, I'll just say 150 so we have plenty of room. So let's fix that window. Some of you have trouble with your window. So the x maximum, I'm going to make 150. That's how far to the right I want to go. And I know the maximum here is 40, 30. It goes up 30. So I'll just make it 50 for the y maximum. Because you want to go a little more, right? You don't want to live in a house where the ceiling's on your head. And check that out. We have a nice quadratic equation here. And you know what they're going to ask you? Well, they don't ask you in this question. They're going to ask you, when will, what's this guy's name? This guy, Amazing Larry, hit the ground. They're going to ask that question, right? So he hits the ground right here. Let me show you a real quick way. See where the trace button is. We can go up to calculate. So we hit second, calculate, and this is called a 0. That's where you can find a root. So you hit choice 2. And here's how it works. Your calculator wants you to go left of the root. So I put the little spider, blinky spider, on the root, and I go left of it. It doesn't matter how far. So I just go a little bit left of it, and then I hit enter. And then I go to the right of it, and I hit enter. Okay, so between these two lines, if you have an older calculator, those lines won't be there. But between those lines is where we're going to hit the ground because this is the height of Larry. So I hit, it says, do you want me to take a guess? I sure do, so I hit enter one more time, and it tells you where the 0 or the root is, 88.989. Woo, that's a lot of stuff. This is all we need to do for now. You have some word problems to do for your homework and practice. Please make sure you ask for questions if you have some, but you have to practice these. We're talking about practice to get good at them. This is Mr. Kelly in Cosmos, and remember, it's nice to be important, but it's more important to be nice. See you.